you want to automate but don't have time to develop the skill set? Try our Easy Motion hardware and software bundle. It's like T-slot extrusions or automation programming. The functional elements are already built for you. All you need to do is connect them together to create fast, easy, and endlessly customizable motion solutions. Learn more at teampipeline.us.
Being very specific about your goals is very important to preventing us from slowing down and having to go back and redo a lot of work in the first place.
Hello and welcome to the Being an Engineer podcast. We are thrilled today to be speaking with David Malouf, a highly skilled senior RF design engineer with over 13 years of experience working in the aerospace industry. He has extensive background in project planning, mechanical and RF design, and process optimization. With multiple patents to his name, David is adept at translating complex technical concepts into accessible ideas for non-experts. His previous roles include engineering positions at Benchmark Automation and Atlas Material Testing Technology, where he led product innovations and testing for advanced industrial systems. David holds a BS in Electromechanical Engineering from Vermont Technical College. David, thank you so much for being with us today.
Thank you so much for having me. I am so excited to be here. Thank you so much.
Absolutely. So we are going to focus today's conversation on our ongoing series, which is how to accelerate the speed of engineering. Before we get into that, can you tell us a little bit about RF engineering? What is RF engineering, and what does the day-to-day look like for an RF engineer?
Yeah. So my role where I work is I'm an RF design engineer, and a lot of that involves product design of different RF components that our company makes. We specialize a lot in aircraft components specifically, both for civilian and military applications. A lot of the daily grind for us probably looks a lot like everybody else's engineer experience, however, where, we go to the meetings, we attend the thing, we see the customer inputs as to what they're seeing. We scratch our heads and bang our heads against the wall trying to figure out a problem that they present us. And just when we feel like it's impossible, we come up with a solution and present it to the customer. And, then there's the whole engineering change orders, everything else, all of those different processes that have the background. But, a lot of what makes being an RF design engineer, especially with the stuff that we work on, is most of our components are just super, super tiny. Many of the modern ones are sub-millimeter, and it's a sort of an art in designing the thing you can't see properly, which has always been a lot of fun. So, there's a lot of that. More recently, I've dove into process design. We're just as much as we're developing products, those products sometimes are cutting on the edge of what is technologically possible with existing, machining hardware. So half of my job is product design, half of it is also new process exploration. So it's been a really interesting ride for the past 8 years now. So it's been a lot of fun.
Very cool. Very cool. Okay. Anything electronic and certainly getting into the niche aspects of electronics like RF design has just been a black box of magic for me. I never get it. So people like you who get those things, I think, are so impressive.
Well, thank you. Thank you. A lot of, I can only claim to know so much about RF theory. I work in a team of a dozen people, and each one of my colleagues have different specialties. And, I work with guys who, I say the same thing, what they do is witchcraft as far as I'm concerned. So I totally get it. I totally get it.
Yes, witchcraft. That's an even better way to say it. All right. Well, moving into the main topic of our conversation today, how to accelerate the speed of engineering. Let's start by talking about what are some of the ways that you have seen engineers slow down that process. Where do we stumble commonly?
Well, I can tell you where I have stumbled commonly. And just thinking about the projects that I've had over the past couple of years, more than anything else, we trip right at the beginning. A lot of the times, a project that I'll undertake is often derailed by me either not defining my objectives clearly enough or not managing my either supervisors or stakeholders' expectations about the outcome of a project. It's been very common where, we'll be, when I say me, I mean, my department will be handed a project to say, go fix this. And then we try to figure out what fix means. So being very clear on our objectives and what we're actually trying to do is key to the success of a project, and where normally we fall down a lot. Also, like I said, managing the expectations of the stakeholders. If my stakeholder says, go fix this thing, and I take fix to mean one thing and don't tell him what that means, there's a good chance that that stakeholder is going to be somewhat disappointed when their expectation may have been something completely different as to what quote unquote fix means. Those are two of like the really easy, low hanging fruit, stumbling blocks that like I think a lot of times, at least in my experience, we kind of gloss over because it's like, yeah, we know, fix the thing. But at the same time, it's like, yes, but does fixing mean we need to get yield rates up? Does fixing mean we need to improve the cleanliness of a process? Like being very specific about your goals is very important to preventing us from slowing down and having to go back and redo a lot of work in the first place. So
I think
yeah,
that's brilliant. That is so well said. I have a theory about why this is, because
yes,
I've found the same to be true in our company, in my in my different histories of working on engineering projects, and at least this is true for me, and I think it's probably true for a lot of other engineers as well. The upfront work of defining the requirements and the objective is not fun. It's
not.
it's paperwork. It's tedious. And one of the reasons I don't like leading projects is because I have to do those things. I have to make sure we have a very clear requirements, documentations, specifications defined upfront. And it's just drudgery for me. I don't like doing it. I want to get into the fun stuff, the creative stuff, right? Let's jump into CAD and design something and go make a prototype and like test it on a benchtop. That's the fun stuff. But the documentation of the upfront requirements, it's not fun. And so we don't always do it, even though we all know that we should. That's at least my theory on it.
I couldn't agree more. And like, we're all really good at the fun stuff too. Like, I'm happy to dive into SolidWorks and just tinker endlessly until I get something perfect. I just may not have defined what perfect might be. So, absolutely. I totally agree.
Yeah. Okay. All right. Well, let's see. How about some tools that you have seen used effectively to fail fast and fail inexpensively?
Oh yeah. So fail fast has kind of been the theme of our department for the past couple of years. The company I work for is a rather large one, and so we have a lot of large moving parts that are often going on in our projects. And it has been so often where either we've not revisited a project or recalculated a project that we end up wasting a lot of time getting halfway down the pipe just to figure out that, this is not something we need to do. And so really, again, it's that upfront looking at the project, doing the boring stuff of being honest about like whether your project actually has a decent ROI. Like we have internal metrics for what a project we would like to have a return on. It really depends on what that project is, and basing your budget off of that projected return on investment is super, super important. Obviously if I'm going to develop a multi-billion-dollar machining platform, and the ROI of that device turns up into be like 23 years, like that's probably not a project I should take on, and we should just stop right now. Um, but that also is a good benchmark for how to guide the project in maybe a different direction. If you realize that like your return on investment is very, very small, but like it's still for whatever reason, for another reason, might be value add to whatever you're working on, there might be a way to go about it just in a different way. So being very honest and objective about what the return on a project is can save you a lot of headache down the line. And just like I said earlier, that whole project chartering and planning thing that we all hate to do at the beginning, like one of the things that our group is really, really good at is looking at and the input to a project and saying, okay, is this insane? Is this something we want to take on? Is this something that we can work with? And oftentimes that project planning and chartering, we can decide very quickly. It's like, oh no, this is actually something that we can do. There's value add to it. And then adding the ROI into it, you very quickly can assess whether a project's actually worth exploring. Now, what's important with that as well is that most large projects like that, they end up being, depending on where you live and who you are, either a stage gate or a phase gate process. One of the best things that we have found that we can do is actually at the end of each one of those stages or gates, go back and look at that ROI and that charter again and see, are we still doing that? And does this still make sense? One of the common problems that we've had, even 5 years ago was we would get so hell bent on a project that we just keep going and going and going and never actually stop and say, is this project even relevant anymore? Does this make sense? And, I'm sure there were times where we probably should have stopped the project and just carried on anyway. But nowadays, it's actually like we kind of pat ourselves in the back when we kill a project early, because that means that we have just not expended a lot of resources that could have been spent elsewhere. So those two things of chartering and ROI are super, super important to do both at the beginning and just throughout the project to prevent anything from any real unnecessary expenditure of resources.
I'm curious to hear how your teams have dealt with what I'm going to bring up next.
Sure.
It's really just a callback to what I said before, which is that I don't myself and probably a lot of other engineers don't enjoy doing the defining requirements for a project and then being diligent throughout the course of a project to look at, all right, what do we project that we're going to spend at this point? What are we actually spending? What are we trending? Are we going to be on budget? Are we going to blow the budget? How do we course correct? These are the things that most engineers don't love doing. We can do them, but we don't love to do them. How obviously they're important. They're super important. Like you mentioned. Have you found effective ways to ensure that these things get done? Is it just having the right person in that role?
I would like to say that I've had a perfect solution to this. The way that we have found to do this is actually through a lot of our projects at a very high level are run through a series of checklists. Like I know that sounds super cliche, but one of our checklists is talk to the plant comptroller to see if this financially makes sense or if we're just doing engineering math right here. Because I absolutely agree. Like the idea of sitting down and doing an ROI or an IRR or an NPV calculation for a whole project just sounds mind numbing. Some of it is definitely getting the right person. I have, with how our projects are set up, we actually have, for large scale heavy lift work, dedicated project management groups that actually will come in and take over a project and do a lot of that. I don't want to call it minutia because that feels like an insult to their job. But the very important but very dry stuff that is required for a project to run effectively, and it leaves us engineers to run off and go do all the fun stuff then. But for mid-sized projects, like, honestly, having other people in your organization you can go to bounce ideas like monetary information off of is super useful, whether it is, if you're in a factory, your plant controller or, some accountant person, My supervisor likes to joke that, a lot of engineering is actually just accounting. And I would very much like that to not be the case. And so having those quick conversations with those experts actually foregoes a lot of that guesswork and everything that normally we'd have to take on.
You mentioned something that is a perfect segue into the next question. You mentioned checklists. I would love to hear what kind of checklists you have seen to be effective in, accelerating the speed of engineering projects.
Yeah. So checklists are a big hot button word in our factory right now. And the one that immediately comes to mind is something we refer to as our transfer to manufacturing checklist. And with how our organization is structured, like I work in the design and development group. We're dedicated to new product development, new process development, kind of weird off the wall stuff. But at some point, it's got to become real. And so we've recognized, and this is something we actually only taken on more recently because we've recognized how difficult this process really is of handing a product to a factory. We have a dedicated checklist that makes sure that we talk to each of the department heads in the factory. We talk to the machining group. Did you look at the drawings for this part? Is this something you can actually make, or are we kind of out in the middle of nowhere with this design? Bringing in the quality department and having their own separate checklist. We have this massive document and massive is probably an intimidating word to use. We have this document that is broken up into different sections that has a lot of tiny little checklists that we hand off to the different sectors of our factory. And, in practice, it's somewhat more muddy than how I'm describing it right now, but very loosely, we basically gather all the people into one room and say, this is the checklist for X project or X process we're trying to introduce. Does this make sense? Are there things that we need to add or remove to this list? And then, by dividing up that labor, we can actually accomplish all those things and make sure that when we transfer a part to our manufacturing group, everybody has signed off on it. Everybody has checked it. Everybody has looked at it. Or, the same thing with a process. Like we're introducing a process that has some concerns where safety is concerned, for example. So we have a dedicated safety officer in our factory who has their own checklist they go through. But that big transfer to manufacturing omnibus checklist really helps us guide the process of making sure that all of the information gets where it needs to go in our manufacturing's hands without trying to forget anything or without losing anything in the process. There's no such thing as a perfect process. But another thing that I found has actually been really useful about checklists, just speaking in abstract, is if you've got a process that you repeat over and over and over and over again, chances are it can be reduced to a checklist, but there is a fine line you kind of need to walk between reducing that to rote memorization checklist that is going to be the same every time and being so inflexible that you can't actually modify when something different comes to you. Our factory by and large makes coaxial RF components, but every once in a while we do something different. And our checklists have to take that into account when we get those weird oddball requests that come through our group and then flow on to my poor manufacturing friends down the line. So yeah, checklists are a huge, huge part of that. The only other thing I'll say to that is that checklists are only as good as the system you use to manage them. I have seen a lot of people manage checklists through sticky notes, simulating a Kanban board with sticky notes. I've seen some people try to do it in Excel. A colleague of mine and I, a couple of years ago, actually introduced a purpose-built project management software to our system. And running our checklist through that and our processes through that has actually kept us more organized than, Excel or even, I would say, MS Project for those of us who have, had to suffer through that before. But having your checklist in a place that is manageable is just as important as having the checklist itself.
Yeah, as you're talking through all of this, a thought that has come to mind is that a lot of these factors that really do move the needle in terms of speeding up engineering projects, they're not rocket science. In fact, a lot of them are pretty basic, having checklists, making sure that you're communicating with team members. They're defining requirements right at the beginning, looking at your budget and managing the budget over time. They're not rocket science. You just, you need to have enough experience to know that they should be done. And then B, you just need to do them, or have someone responsible for doing these things.
And that's the crazy part about this is, I've had multiple conversations. A cousin of mine is actually just graduating engineering school soon here, and one of the things I encouraged him to do is take an English course and take an engineering ethics course. Like, those are going to be your more important courses, because I have no doubt that if you graduated an engineering program, chances are it's because you survived it and you're going to do okay. But if you can't communicate the knowledge that you have, your usefulness is going to be very limited. So, for engineering students who are in school, take the opportunity to take English courses, take technical writing courses. That technical writing especially is a skill that I think is massively undervalued in our industry. I'm sure you've received emails that are supposed to be some sort of description of specifications, but end up being like this rambling description of pseudo nonsense I'm going to try to pull something out of. I've never received that. Never ever have you seen that. But just that ability to communicate clearly and succinctly, hopefully, skill I'm learning, is something that I highly recommend everybody take up at some point if they can.
I agree 100%. So much of this comes back to just good communication, which is, I feel like, something that is not really well defined in our industry. Everyone talks about communication. We all know that it's important, but it's this nebulous, fluffy thing off in the ether somewhere that none of us can really nail down and define well. Well, some of us can, but most of us, it's just this idea that's floating out there in the clouds. I remember taking a technical writing course in college, and I loved it. It was one of the most enjoyable classes that I took. And over the years, I've learned that I'm actually a pretty good technical writer, and that's probably why I liked it. I just happen to have an innate...
It just clicks in your head.
It does. Yeah. I enjoy that. And honestly, I think that's one of the reasons that I've not that I'm some mega success or anything, but I think it's one of the reasons that I've been at least marginally successful in growing an engineering business, is because I think I'm fairly good at communicating with people, and that's such an important skill.
Undoubtedly, it is. Like I said, your ability to communicate your ideas is a way to be able to be more useful. And if I've got plenty of colleagues who, because I speak engineerese, I know how to talk to them, but for translating something from what they know, this highly technical thing, to, even talking to supervisor groups or stakeholders, or even just a layman out on the street who has the unfortunate consequence of hearing me talk about engineering, it's a skill unto itself to be able to take that knowledge and put it into something understandable, for sure.
Yeah. There's an engineer that I worked with for a while, and he was one of the smartest engineers, one of the most technically gifted engineers I've ever worked with to this day. He did things that I certainly can't do, and most other engineers I've worked with can't do from a technical standpoint. He was just brilliant. When he talked to me, I understood the individual words he was using. But I kid you not, half the time I had no idea what he was trying to communicate to me. And it was so frustrating. And it held him back. It really, truly held him back in his career. He did not advance the way he should have, given his technical skills, because he couldn't communicate well with others.
Absolutely. And it's a shame too, because I'm sure that person has brilliant ideas that if only we could execute on would benefit whatever they happen to be doing. No, I can't emphasize enough. Just being able to communicate clearly is such a skill.
Yeah. Yep. Absolutely. Okay. How about feeling safe, psychologically safe? How does that affect a team's ability to make rapid progress versus, I don't know if I want to say this because what's he going to think about it, or what she's going to think about it, or what are the politics involved or the bureaucracies? Talk a little bit about psychological safety and how that affects an engineering project.
Yeah, so actually, this is something we're just coming off of doing in our department. So the summer's ending here, hopefully in Arizona at some point.
Oh, I sure hope so. Good grief.
God, right? And we just had a cadre of interns, and one of the things that we really like to do with our internships is treat them as basically full-fledged engineers. That's what we told them day one when they joined up. I had one working directly for me. And when we take on interns, they function as engineers for the summer. We don't assign them like the stereotype get coffee or whatever, and, do all the minutia stuff that we hate doing. I still did all the minutia and they did more fun things. But one of the things we do every week is we have, our staff meeting, and we drag them into it too. And because they're part of our staff. And one of the things I find so often is, and I remember feeling this when I was a new engineer too, is that very feeling of, God, I'm surrounded by like centuries of experience and I just graduated. I have no idea what I'm talking about.
Yeah.
When really you actually might, because those centuries of experience happened a long time ago in some degree. So you might have more information on a current topic, especially, with the rate of technology and how it's advancing. I mean, when I graduated high school, cell phones weren't a thing yet. That's how recent that is. And so, for a lot of modern factory equipment, for example, is using either Bluetooth technology or some sort of wireless protocol or something that some of my more senior engineering folk may not have grown up in and around and may not know how to use even. And so, especially with more relevant things like actually having the younger folks speak up in those situations is extremely helpful. I think as somebody who's sort of mid-career, the best thing that somebody like me can do to encourage that behavior, especially if you're looking to get that information out of the younger engineering staff, is just start talking yourself. Just throw an idea we throw around a lot in our shop is a lot of people are scared of a blank piece of paper, but everybody can do edits. And so oftentimes if I feel like either a group is stalling, or if like I get the sense that like, man, that new grad wants to speak, but he's just keeping it in for whatever reason, I will throw out the worst idea I have and just say, let's start here and then make this better. And that often facilitates that discussion because I've already looked pretty dumb. And so you can only go up from there. And I'm confident enough in my ability that I feel okay looking dumb in front of my colleagues, senior and, younger. But that's sort of something that a mid-career engineer can do, especially if they have an interest in fostering this sort of discussion and providing this sort of space where younger engineers can add their ideas in a way that feels safe, for lack of a better term.
I love that. Those who have been listening to this series are probably going to start rolling their eyes because I keep bringing this up. It keeps coming up, and I love this term. A friend of mine uses the term McDonald's ideas to describe exactly what you're talking about.
Yes.
They'll go out to lunch, him and his team, and he's a leader in his team, and they'll say, well, where should we go for lunch? And everyone's like, oh, I don't know. I don't know where you say, where should we go? And so him as the leader, he'll say, oh, let's go to McDonald's. And everyone looks at him like, what? I can do better than that. I mean, I'll give you a couple of ideas. Okay. I don't want to go to McDonald's. So he calls those McDonald's ideas. Exactly like you said, right? Just a great way to start some communication, some discussion in the group. Throw out a bad
Absolutely.
idea.
Absolutely. I love that idea. I might steal that. This McDonald's ideas. I love that. Oh man. No,
Sorry, McDonald's.
it works. So, yeah. I love the dollar menu. Don't get me wrong. Um, but no, it's absolutely true. Like just the sometimes just to kickstart that brainstorming or creative process, you just got to have something on the piece of paper, even if it's just spilled milk.
Yeah. Right. I like your way of describing it as well. Everyone's scared of a blank piece of paper, but is able to make edits. That's a great way to think of it. Yeah.
It's something that like I not to brag on myself at all, but like I've always just sort of idea vomited or word vomited on a piece of paper just to get it out of my head so that I could work with it. And that has really driven this idea of like something's got to be there first before we can do anything with it in the first place. And I see just a lot of people get frozen in that initial step, and just a little push is all you need.
Yeah. This deviates a little bit from the question of psychological safety, but when I was in college, I remember getting stuck on some engineering problem or physics or math, something, and I didn't know what to do from where I was. And I asked a roommate of mine for help, and he didn't know exactly where to go either, but he had this great way about him of just trying something. It didn't even matter if he thought that something was necessarily going to lead directly to an answer, but he would identify, well, here are 3 things we could do. I don't know that any of them are the right things, but we can try these things. So let's try them. And sure enough, we'd try a couple of things and we'd figure out a path to the answer. And I always thought that was so clever. When you get stuck and you're not really sure where to go, just try something. And even if you think to yourself, this more than likely is not directly going to lead to the answer, but I know it's something I can do. So I'm just going to try it and see where that leads.
Absolutely. And especially, just thinking about the context of problem solving. If I'm staring at, I admit very freely my ability to program in any language whatsoever is suspect at best. But if I'm looking at something like a program, I know I don't know everything, and I know that there are people who are going to know things that I don't. But even if it's something that like we're all staring at and we know that this is not working properly, but we don't understand why, at least trying something gets us data. And that data we can then use to guide the next step and get that iterative problem solving process going.
Right.
And it comes right back to that. Just we need to jostle the system some way to get it to tell us something.
Yep. A little kickstart.
Absolutely.
Well, let me take a very short break and share with the listeners that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering, where we don't design pipelines, but we do help companies develop advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services. Learn more at teampipeline.us. The podcast is also sponsored by The Wave, an online platform of free tools, education, and community for engineers. Learn more at thewave.engineer. And we have the privilege today of speaking with David Malouf. David, have there ever been experiences where you've introduced a new technology or a tool that significantly reduced engineering time?
Yes, actually. I mentioned earlier briefly that a colleague of mine and I had introduced a project management system to, at first, our department, but then it's now grown and expanded uncontrollably. Before that, we basically, when we were managing things like new product design or process improvements and such, we were one step away from handing a piece of paper around, checking checkboxes off and doing that kind of thing, which is great so long as you know where that piece of paper is. We've lost that piece of paper a lot. I used to be very skeptical about project management systems. The extent of my experience had been an older copy of MS Project, and it's great at doing like a couple things, but as soon as you start to introduce a lot more complexity, you can really get bogged down in the minutia and details. So, when we selected a project management system, we looked for one that was very flexible and we could get it to do a lot of things, but was also very lightweight. One of the things we find more than anything else, and this is, I've worked with companies of all different sizes and worked for companies of all different sizes. This is definitely a problem on the larger corporate side where we will get bogged down in all of the red tape that we have everywhere. And one of our objectives with putting this system into place, and my colleague has now run with this system and developed this fantastic platform. One of the things has been making sure that whatever interactions we have to have with this system is easy, quick, intuitive, and I don't have to spend a lot of time teaching, my 40 plus year veteran engineer how to operate this system, nor should I need to teach my brand new greenhorn engineer the system either. And so by introducing the system, we now can actually measure the time accurately that we spend on things, and we're finding that it's actually picking up. One of the points of pride for our department, actually, with a lot of design turnaround is we can now turn around design from customer reaching out to us to, getting ready to hand it to manufacturing. Most of them turn around in under 30 days now. And that is something that, as far as I'm aware, is unheard of in the industry. And a lot of it has to do with the fact that we have a very well-defined process, and that process is not managed through a piece of paper we hand around, but a system that is centralized that we can go to, pull the information from, input the information that we need, and we don't spend all day managing the system. The thing that we are terrified more than anything else is that we then end up with a system to manage all the things we're trying to manage in the first place. That is just management, stacking, nesting eggs type of thing that we want to avoid. Absolutely.
This tool that you're using and have grown throughout your team, is this an off-the-shelf product that anyone can purchase, or is it something homegrown?
Yeah, so this is actually an off-the-shelf product. It's an open source piece actually called Open Project. And it happens to be the system that we found met all of our needs. And, we really like it, but we've looked at, a bunch of different types of project management and process management systems. And I think if an engineering group or team or even a manager were interested in looking at something like this, I think that the best thing you can do is just try it out for a little bit. We did a lot of trials with a lot of different software, and we found a lot that kind of matched what we needed, but a lot that kind of didn't. And, if you are interested in implementing something like that, the best thing I can say is just experiment with it and try it out. Get your hands dirty before you go full blast into putting it into place.
Yeah, definitely. Open Project. I've never heard of this before. I'm very curious now to check this out.
Absolutely. We've had very good experiences with using it so far. I believe it's developed primarily out of a group in Germany, but yeah, we really, really like that system.
Cool.
It's worked really well for us.
Terrific. All right. Yeah. I think we are kind of in the market for a new project management system. We've used one for a while, and there are definitely opinions within the team about moving to something else. So Open Project, I'm definitely going to take a look at that. Great.
Yeah, absolutely. I highly encourage that.
Great. Thank you. All right. Have you ever, are there any experiences that you can share or stories where an attempt to accelerate your engineering activities, a project backfired? And what can we learn from that single experience that never happened more than once?
Oh, never happened more than once whatsoever. I could say that, God, I could think of a half dozen projects like that. The big thing I can say is if you understand the size of your project, treat it appropriately thus. We undergo a lot of things that we refer to as tasks that, maybe in some circumstances might have qualified as a quote unquote project. We're very specific when we want to be about that word project. And a lot of times those tasks are, what we think of as like fix it tasks or, like minor change tasks that, maybe sometimes should have more interest in, not interest, but more rigor or evaluation to it than we should have done at the time. I find that generally, if we try to skip steps that are put in place for a reason that often we have put in place, we end up fouling our own process. There are several products that we have gone through the prototype stage. Actually, one that we developed very recently where, we went back and forth with the customer a lot, and a lot of our time is spent in prototype. I recommend anytime an engineer is considering doing prototyping, budget like 3 or 4 times as much time as you need for that, because you're going to be there a while. So we were having a back and forth with the customer, and normally we get a lot of information up front, but we didn't ask all the questions we need to, and we made some assumptions about the thing that we were trying to build. And this is very fortunate why we put all these checks and checklists in place in our system to make sure that we check all these things. But we did get to the end of the development process and moving to prototype when we turned around and handed the customer and said, oh, but what about X, Y, and Z? And it was something that we should have asked up front that is actually in our list of things to ask. And so just by not following our own checklist, we actually fouled ourselves. We were trying to go a little bit quicker and ended up having to just redesign the entire thing from start to finish. So yeah, that's a really common, I don't want to say common, it's definitely less common now, but something that we do run into on occasion is just we don't gather all the information at the beginning.
So let me ask you this, because we have certainly done this as well. We've skipped a step to try and move faster, and then it bites us in the end, and we end up going slower overall. And I'm thinking to myself, why is it that we do this, and why is it that it happens again, like you said, not frequently, but like on a recurring basis? There might be years in between each recurrence, but it happens, and then it happens again. And is it because we've had some good experiences doing this? There have been just enough experiences where we've skipped a few steps to speed things up, and it actually has sped things up. So then we think, well, maybe I should just do that again. Mm-hmm. Is that the case where we're winning just frequently enough to keep us coming back to that blackjack table?
I think there's some truth to that for sure. Just thinking about my career and what we've taken on for different jobs and tasks and things like that, there have been plenty of times where, we've made whether we're pretty sure are safe assumptions, and we have been able to accelerate those things. I think that when we're thinking about doing those, potentially skipping steps and things like that, the failures happen just often enough to have forgotten really the failure that we had last time is what I have found.
Right.
And for us, just thinking back, like sometimes there are years in between it, but like if we take on 2 very different design projects, for example, I can see a potential where we might repeat the same mistake very quickly twice, just because we're looking at an entirely different animal of a project. So that's why it's just so much more important that like those checklists that you develop for your process, like not that they're word of law, but like there's a reason you put those items there in the first place. Yeah. And let's just check them all off just to make sure. And I say this out loud, and I say this to me knowing that sometime a year from now, I'm going to have forgotten about saying all this and skipped another step. Something we all do.
Yes. Remembering history is a big point in preventing it from recurring, isn't it?
It is.
We have a little project checklist that we go through every time we start a new project. It's setting up the folders and it's notifying the right people, things like that. And occasionally we'll get just a tiny micro project. We don't really do these very often, but every now and then, for whatever reason, we'll take on a project that's like, a few $1,000s. It's almost nothing. And I'll think to myself, man, I really don't want to go through the process of setting up this $2,000 project in our system.
Yep.
It's just like a total waste of time. And so I'll think, I'll just skip it this time. And every time it bites me. Every time we get to some point or like, shoot, we haven't tracked this. I don't know where we are with that. I didn't let this person know. It just bites me every time. So I have finally, at least in that specific instance, learned just follow the checklist, because it's going to bite me no matter what.
Absolutely. A colleague of mine, he has a really good saying he likes to go to, which is automate the boring stuff. And so, to the best possible degree that we can, folder generation is a great example where we actually will take even something as simple as like a folder structure template and just copy paste it just so we have that.
Yeah.
But even that little bit of structure helps remind us that, okay, we actually have to do all these other things in this list too.
Yeah. Right.
But like, absolutely understand that $2,000 project suddenly gets a lot more expensive as we miss more and more steps. So I get it.
It goes back to not wanting to do boring things, not having the discipline to do the boring things.
Yep. Absolutely. I understand completely.
Has there ever been an unconventional approach that you've taken to expedite engineering processes?
Unconventional is the nice word that people have used to describe it. So a lot of times we are, especially in the group that I work in now, we are looking at either technologies that have not been, fully evaluated in our particular application, or, and even more so as we dig into smaller and smaller machining practices, things that have just really never been done before. And there are some guidelines for how to set up a project for stuff you've never done before, but you almost kind of have to accept the fact that at some point you're going to spend a lot of time kind of questioning reality at some points. You're going to spend a lot of time asking, like, is this really a thing we can actually do? And what I have found is sometimes very, very useful. And I only recommend this within like certain contexts and certain, I guess, latitudes, for lack of a better example, or lack of a better term for that. Just grab the thing you want to do and try experimenting with it just for a couple hours. In our department, we have several 3D printers now that we do a lot of rapid prototyping with. And it used to be the case that like we would have to wait for our manufacturing group to open up a machine so we could get a prototype and have them make it. And 6 weeks later, we knew we were wrong. And instead, we can take the idea, rather than set up this whole big thing where we've got to get budgets for taking machines down and everything like that, and just very quickly try something, even if it doesn't make any sense initially. And actually, the rise of 3D printers generally has enabled a lot of this in a lot of different sectors too, where it's encouraged a lot more experimentation up front. And what I've actually found is especially in product design, if you can do that little bit of experiment up front just to understand whether something is even sane to take on, you can actually avert a lot of going through that ROI calculations that I talked about earlier and everything, all the boring stuff that we don't want to do in the first place, just by doing that little bit of experiment first. Now, I have several engineering professors, I remember, who would slap me for saying that. But sometimes it just takes getting a wrench or a hammer and just beating on something until you see whether it makes sense or not initially.
I think that is such wise what's the word I'm looking for? A recommendation. It makes so much sense to spend those few hours just trying something really, really rough. We have a whole bunch of 3D printers here as well, and there's one. I won't say the brand name, but we have a couple of this brand of printer, and they do a really nice job. It prints with carbon fiber, really nice parts. Part finish is great. The material's a little bit expensive. And whenever an engineer would print with those printers, we have a little form that gets filled out so that we know how much to bill our customers for something we 3D printed for their project. Sure. And so they fill out this form and they put the price in it. And they ended up noticing that our internal cost, or what we charge the customer to print this part with this internal 3D printer of ours, even though they're really nice parts, we're often a little bit more expensive than what it would cost to just like go out and buy it from a service provider, a 3D printing service bureau. Yep. And psychologically, even though, they would spend time, if they went with a service bureau, they'd have to spend time like sending files and getting a quote and issuing a PO and all that stuff. And so really it was probably still cheaper just doing it internally. But psychologically, they'd see that price and they'd compare it with what a service bureau would charge. And they'd be hesitant to do it. And it would take extra time because they'd go back and forth. Oh, what should I do? Should I do it internally? Should I send it out? And so we identified this as one of the roadblocks that we were going through. And what we did was we bought a relatively inexpensive, about $1,000 3D printer that's really very reliable and actually produces great parts. Not as good as this more expensive one that we had, but really pretty great parts for what it is. And we just said, okay, guys, from now on, if you use this new 3D printer, the parts are free. We don't charge the customer anything. It doesn't burden the project with any cost. It's just part of our overhead. And even though, the company's still incurring that cost, right? They don't see it added to the project, and they don't see that charge getting passed on to the customer. So it feels so much easier for them now to just use this 3D printer. And, maybe in the past they would have done 2 printed parts to prototype because, it's kind of expensive. I don't want to spend the money. I don't want to burden the project. Now they'll do 10 because it's free and it doesn't cost them anything. And guess what? We actually do projects much faster and get better results. All of that just because we have this quote unquote free 3D printer in house now.
That is fantastic. And that mentality of standing in front of the more expensive printer and like second guessing whether this is value add or not. Like one of the things I try to remind, especially new engineers coming in is like the cost of you standing there still adds somewhere too.
A lot.
And, the couple hours you have spent thinking about, should I print this or should I send it out? Like probably was the cost of just printing it in the first place.
Definitely. Yeah.
And so like having that, lesser is the wrong word, but like quick and dirty 3D printer. And, we have something similar. We spent maybe $1,000 to get a printer to do mostly fixturing work, but like, it's actually, I'm always amazed at how rapid the 3D print industry has actually come. I remember, when I moved to Arizona in like 2012, rep wraps were just coming out and being a thing. And now we've got these printers that like are, sub-millimeter accuracy. And it's kind of crazy what we can get out of them.
Yeah.
But absolutely, just that ability to rapidly iterate, rapidly prototype, and not have to worry about whether the thing I'm making, if it's wrong, there's a huge consequence to it. Failing fast and the freedom to fail is so critical in any project.
Agreed. Well, David, what a marvelous conversation this has been. Thank you again so much for sharing some of your time. Absolutely. Yeah. What a treat. How can people get in touch with you?
Yeah, so you can find me on LinkedIn pretty easily. That's most of where I find myself these days. I have not just an interest in RF theory, but a lot of my time has been taken up now through the concepts of like, how do we make engineering better and how do we make it better for the people that are coming up behind us? So, Yeah, more than happy to talk to anybody who's willing to listen to me natter on for a while about that type of stuff over LinkedIn. Please reach out.
Awesome. Thank you so much, David.
Absolutely. Thank you.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.